Hi, civil and structural engineers. This is Chevin Academy. Welcome back to another exciting section of TEKLA TEDDS series. In this section, we are going to be looking at timber joist design. But before we dive into the design, I would like to give you a simple introduction to timber structures. First of all, what is a timber joist? A timber joist is just a beam that is arranged in parallel at a particular spacing in order to support a floor, which most of the time can be a wooden floor or can be steel floor. So it supports floor or ceiling. So let me give you a quick introduction about timber structure in general. A timber structure is a structure in which the main load carrying structural elements are made of timber. So when we talk about a timber floor system is made in which a slab or a floor or a ceiling is made of timber. So what are the components of a timber floor system? The main component of a timber floor system include the deckings, then we have the joist, then we have the beams. So the decking is like a slab in which it's going to provide a flat surface. Then this decking is supported directly by the joists that are arranged in a given sequence. So then what supports the joist is the timber beam. So the timber beam and the joist are actually the same thing, but the only difference is that the timber beam are larger in size compared to the timber joist. So the mode of transfer of loading is from the subfloor. This subfloor can be made up of decking, then to the joist. Then the load is transferred from the joist to the timber beam, or you call it the support or support beam. Then this load is now transferred to the columns. So in most cases, this column is also made of timber. So the spacing of the timber joists are actually given based on the specified code that you are using, depending on the region or depending on your location. So for this tutorial, we are going to be looking at timber loadings. So on TEKLA TEDDS, we can easily determine the self-weight of the timber joist. Then we are going to be adding additional dead load of 6 kilonewtons per meter on the joist, then live load of 2 kilonewtons per meter on the joist. So let's move to the next section where we are going to be designing a timber joist to support this load. If this is your first time on Chevin Academy, or you have been coming to our channel but you've not been subscribing, kindly hit the subscribe button to see more awesome videos on TEKLA TEDDS series and also videos on civil engineering design by hitting the subscribe button and turning on the notification. You can also like this video, share it with your friends and your professional colleague. This is our TEKLA TEDDS series. So before we start the project, I would like to explain to you what we mean by the difference between this document and project on TEKLA TEDDS. If you look at TEKLA TEDDS very well, you see most of the things you see is either you see open a document or you see open a project. The difference between document and project is on document you can easily create a simple design and then save the design and use it. But when you are talking about project, just like the name, it's like you want to create a project. So in this project, you can have a series of calculations. For example, using a timber floor system as an example. In a timber floor system, you have to design the decking, you have to design the timber joist, you have to design the timber beam. So in this case, it will be proper for you to create this design using a project, because it has comprised of more than one design template that you have to run. So because of this, you are going to be creating a new project. So you can just do that by clicking on create new project, here. So once you click on it, then it will be best for us to rename our project so that we can easily identify it. So you can double click on this project icon, just double click around it. So once you double click around it, then you can easily rename it. So for the case of this tutorial, I'm going to rename it to timber floor system design. That is the name of our project, timber floor system. So under this timber floor system, that's when we now have the design of timber joist, the design of the decking, and the design of the support beam, onto the design of the column and the foundation. So in this video, we are looking at design of timber joist, in which is going to be supporting an additional dead load of 6 kN per meter and a live load of 2 kN per meter. So what we just have to do, now we've created the project, the next thing is now to create a document inside this project. So just come to this project manager under this box. You can actually increase the size of the box by moving your cursor to the tip of the box and then drag. So you can just right click inside and add new document inside this. So I'm just going to create an add new document. But before you go, for professional work, you might want to edit your header, your footer, your logo. You can easily do that by just coming to edit project header. So if you want more video on this, you can check our introductory video on TEKLA TEDDS. So I'm just going to add new document. So once I add new document, then I want to design a timber structure. So I'm going to come to timber. So in this case, I'm going to be running a timber analysis and design. You can easily come here. You see we have something like timber member design, but because what I have is only my loading, so I need to analyze before I do the design. So I'm going to pick timber beam analysis and design. In the first part of this section of this video, I explained to you that a joist is just like a beam. So that's why we'll be picking timber beam analysis and design. So but because we are using the BS code, so that's why I'm picking this timber beam analysis and design BS 5268. So once you click on it, then because of this show example that was tick, so it's going to show us. So the software is going to show us a typical example of what we can do with this software. Then you can also see the update on the releases and additional stuff that were added to each update. Then you can see what you can design. You can design timber, a gulam, a composite structure, a fleece, and a ply web member. So those are the things you can design. So the next thing you just have to do is you come to calculate. The calculate on the bottom right corner here. Click on it. So once you click on calculate, automatically we have our project timber beam analysis and design. So the software is loading. So now the first thing we need to do, if you look at this template here, you see that we have beam analysis, we have member details, then we have design options. So here is where you preview your result. If the results are failing or not, you can easily preview it here. Then here is where you have the output option. Output option means that to generate your calculation sheet. So here is where we have the preview of the timber of the structural elements we are talking about. You can zoom in and zoom out with by scrolling your mouse forward or scrolling it backward to zoom in and zoom out. So the first thing we are going to be doing is our joist is a simply supported beam and the span is 3.5 meters. The span is 3.5 meters. So the first thing we have to do is to come to geometry. So under geometry, we are going to indicate the size of your joist. So come to geometry, click on geometry here. So because we have only one beam which is simply supported, so we are just going to click on this and indicate the size. So because we are working with BS code, our sizing is in millimeters. So I'm going to put 3,500 millimeters. So then this area is calculated from the material, but before we've not selected the material, so the software is using a default timber section. So the next thing after including your span is, let's say you have a continuous beam, you want to put another beam, you want to put another span. That is, you have two span, each of the span is 3.5 by 3.5 meters. So what you just have to do is you can insert new span by add a span, or you can insert a span in between these two span. So if I click on add a span, that means I had additional of existing span. So I now have 3.5 meters by 3.5 meters. If you want to change the spacing, let's say one of them is 3 meter and the other is 4 meter, you can easily do that by just clicking on it, and you'll be seeing the difference on the preview page here. So the next thing after including your span is to add the support condition. So this is support A, this is support B, and this is support C. So for support A, what do you need for your vertical? Vertical means the vertical reactions. Do you want it to be restrained, or you want it to be free, or you want it to be spring? So in this kind of situation, we want, when you say free means there is no support there. If you make your vertical reaction to be free, it means there won't be any support. But when you make your rotation to be free, it means that there won't be any moment at that point. So vertical reaction is talking about the vertical reaction, while the rotation is talking about the moment. So in this kind of situation, we are going to make this thing restrained. But because we are only working with a single span of beam, so I'm going to delete this second span. I will click on it and you click on delete span. So the span is deleted. Then I'm going to change this guy to 3,500, which is the span of our timber joist. Then the vertical is going to be restrained. If I make it spring, you see it's going to have a spring support, but it's going to be restrained. Then at point B, it's also going to be restrained, meaning it is simply supported. Then the rotation is 0 because there is no moment. We are not fixing it. If we make vertical and rotation to be restrained, that means the end at that point is going to be fixed. So, but because in that case, I'm going to make the rotation to be free so that the end of the beam is hinged. So after indicating the span and the support condition, then you click OK. So once you do that, you can see that the geometry changes from the red highlight to something like a normal black highlight. The next thing is now to go to the loadings. So click on loadings. So on loadings, you see by default you have a self weight which have been imposed on the software. So I'm going to add additional load. So I'm going to click on add load. So you can add various type of load. So the description here is you just type in the type of load. I can say additional dead load. Then do you want the load to be fully uniformly distributed load? So we have different type of loading. You can have a fully uniformly distributed load, self weight, fully varying load, partial uniformly distributed load, partial varying load, a point load, and you can also insert a trapezoidal load. When you insert a fully uniformly distributed load, that means the value of the load is going to be uniformly distributed across the beam. But if it is varying, or if it is partial, you only wanted to apply it to a particular part of the beam. So in that case, you can indicate the first position and indicate the second position. So let's say our additional dead load was 6 kilonewton meters. Then let's say the first position, we indicated it to be 1000 mm, and the second position we indicated it to be 2000 mm. You see that the load is applied to only some parts of the beam, and you can also notice that so the next thing now is to come to, but because the load we are going to be applying is going to be uniformly distributed and it's going to cover the whole part of the beam. So we choose full uniformly distributed load, so it covers the whole part of the beam. And you can see this type of load is a dead load. So the next type of load, we can see that in this case we now have load cases. That is, for each load, what type of load are we applying? So because this load case, the first one is the self weight, and the self weight is also a dead load, so we leave it as dead. The second one is an additional dead load, so we change the load case to dead. I hope that is clear. So then the next thing is now to add the third load, which is the imposed load or the life load. So you just click on add load. So in this case I put it to be life load or imposed. So it's also going to be uniformly distributed, and it's not going to be the type. We are going to leave it as life or imposed for the type. So we are going to change it to imposed load because it's an imposed load. Then the value is going to be 2 from the data that we've given earlier. So you can see the value, you can see that the imposed load was given a different kind of color. So if I change this one to 0 so that you can see the color very well, you can see the color of the imposed load, then this is the color of the dead load. So now that we've indicated our load, so if you have other kind of load, you can also indicate it by just following the same process. So on the software, you can input dead load, imposed load, roof imposed load, life load, wind load, snow load, and other types of loadings. So once you are good with the load, the next thing is to click OK. But in case you want to delete a load, you can easily select the load, then you click delete load. You can copy a load and paste it. So let's say you have a load in different location where it's the same value, you can easily use the copy and paste. So because we are good with this information we have here, then we just click OK. So it's saying that the load case name must be unique. Load case 1 and load case 2 have the same name. So we just click OK. So because this is also a dead load, so we can easily change it. So let's just put it as other load. Then we change this thing to other load like this. Then we click OK. So that is our load. Then the next thing is now to define your load combinations. So you come to combinations. So under combinations, we have all the types of load that we have. So the first combination is we can include a service load, service limit state, which is applying a factor of 1 to all the load cases. Then for the other one, we have to apply a factor of, so I include another load case, which is this. So you can easily name each of the load case. You can name it. You can say this one is service limit state load case, SLT. So for your load case 2, you can name it as ULS, ultimate limit state. So for my dead load, I'm going to put a factor of 1.4 for the dead load. Then a factor of 1.4 for the dead load. Then this other load is also a dead load, 1.4, and then I'm going to put 1.6 for the life or the imposed load. So you can see the ranges. Then for the support load factor, in this case the software is trying to divide the load into support and the span. So you just indicate the same thing. So for the dead, 1.4, for the ULS 1.4 for the support at point B. Then here you put 1.4 as well. You put 1.4 here as well. Then for the imposed load, you have to make it 1.6. Then so this is the service load, this is the ultimate load. Then you click OK once you are good. So the next thing is now to move to the member details. For the member details, you only have two options. You can determine the type of beam, maybe timber, a gulam, composite, fleece, and ply web. In our next in our subsequent video in the future, we'll be making difference between all this kind of type of beam in a timber design. So but the purpose of this course, we are just going to make timber as our option. The member details, that is the size of the members. We have different kind of timbers. So here you see the member details. This is the breadth of the section, this is the depth of the section. So for this course, we are just going to use 25, which is 1 inch by, and the depth is going to be 75 mm, 25 by 75 mm as our joist section. Then the number of section is going to be 1. That is, we only have one of its space at different spacing, not 2 as shown in this. So when you pick 2, it means you have to have a connection to make 2 member section join together. So I'm going to pick 1. We only need 1. Then you now come to the timber properties. Timber properties is the properties of the timber, and this one indicates the size, the class of timber. In timber design, we have different classes of timber. So in this case, I'm just going to click OK without changing any of the properties here. Then the next thing you have to do is click the service class of the timber. So for this case, we are going to pick each of these class. You can see the definition of each of the class. Class 1 says, class 1, if you look at the top here, class 1 is characterized by internal use of continuous heated building with an average moisture content of 12. So each of the class is differentiated with their moisture content. So I'm just going to click OK here. Then we can pick class 1 because it has very little moisture content. Then this one is the load sharing system. So you can just leave this one as it is. Then the rotation of the beam, what angle do you want the beam to be? So we just want it to be laid parallel, so we are going to make the angle 0. Then you can now see the section 25 by 25, class of 24 timber. Then the bearing length of the beam, by standard you can pick the bearing length of the beam to be 100 mm. Then the beam is not notched. Do you want it to be notched or not? That is to have this kind of support. So it's under no notch. If you want top notch, you have to indicate the size and the breadth. So but for the purpose of this tutorial, we are not going to go into that. So we are just going to click OK. So we move to the maximum depth of the breadth ratio. So just leave this one. It depends on if there are lateral supports or there are no. So we are just going to leave it as no lateral support like this. Then do you have axial load on the beam? There is no axial load, so we are going to leave it as none. Then the permissible slenderness ratio, according to the code, you can use 180 for this kind of beam. So you click OK. So once you run the member, how you've indicated the member, you can now see that you have a kind of a design. You have a kind of a preview result. Preview result is once you've indicated this section, the software is going to design it and is going to analyze, then it will design. Then once it analyzes and design, it's going to give you a preview result. You can see that once we indicate the member design and the member details and the timber type, so you can notice that the preview result now loads some kind of results. You can see the bearing stress, the lateral stability, the bending stress, the bearing stress, bending stress, the shear stress, and the total deflection. So but before we go into this, so let me try to finish the design. Then you can come to the design option. So this determines the duration of your loading. If you are designing a permanent structure, so you can pick a long-term loading, or if it is an accidental load, very short-term, or a short-term, or a medium-term, depending on the type of design you are creating. So in this case, I'm just going to make a long-term because we are creating a permanent timber structure design. So then the deflection criterion is given according to the code that you select. So I'm just going to leave this the way they were. So now coming to the result, you can see that the bearing stress on the capacity of the beam section that was selected, it can only pick a stress of 2.4, and we are applying a stress of 8.128 on it. So that means it's going to fail. That's why this utilization ratio is greater than 1. According to the design, for your design to be normal, your utilization ratio must be less than 1. That is, the stress on the ratio of the stress on the member and the maximum stress in which the member can take. When you divide this by this, so you have the utilization ratio, maximum stress over the capacity. So then if you check the total deflection, you can see the total deflection is 10.5, and the maximum that was imposed on the building was almost a way more. So what we can do is we can go back to the loadings and try to reduce the load. So let's just come back to loadings. Then let's change this load to 1.5, and also change the imposed load to 1, because this is just a timber member. Then click OK. Once you do that, you see a reduction in your stuff. Then the next thing you can do is you can try to increase the member sizing. Just come to member details, then you change this. Instead of having 1 inch, you can see 1 inch is very small, so we can use something like 60 by 170 beam. Then click OK. Once you do that, you see automatically the design is going to redesign by itself. So you can also see that you still have some members that are failing, so you can still come back to loadings again. Okay, we are not changing any of the load. So what we just have to do is you can change the class of the timber. Come to timber details. Then if you come to the service class of the timber, you can change the class. Then, but I'm just going to change the number to 2 so that it becomes more stiffer. Then click OK again. So once you do that, you see a high reduction in the design. You can see that the bearing stress, the maximum is now lower than the capacity. For the bending stress as well, is still a little bit higher than for the shear stress and the deflection. So for the deflection, you just have to increase the sizing, probably increase the thickness, the depth. So you come to material details, you change this to 220, then you click OK. Then you now see that all the members have been designed and the design for all members have passed. So you have your bending stress, the utilization ratio is less than 1, the lateral stability utilization ratio is less than 1, bending stress, shear stress, and the deflection. So the next thing now, when you are done with your design, is to run out your output options. Output option means you want to get your detail, your calculation sheet. So click on output options. Then here you can pick the level of output you want. Do you want the software to draw the member sketch? Do you want it to draw the geometry diagrams? So in this case, it will be always nice for you to pick to tick everything so that you have a full calculation sheet. So you can also indicate the level of output. You can have a summary, or you can have none of the calculation sheets. You only have the load case and the load combination, no calculation. So I'm just going to pick full, then I'm going to check everything. So once you do this, your calculation is ready. So the next thing is just to click OK. So once you click OK, then you click finish. So once you click finish, the software is going to generate your calculation for you. So let's move this guy to this side and then reduce the size so that we can see the calculation sheet very well. So you can see this is the header. So in case I change the logo, you have the logo you change to here. Then this is going to be the project name. You can easily edit that from the project header. The calculated by the date. The date is going to be the date in which you are generating the calculation sheet, so it's automatic from the software. Then this is the beam. You can see the beam. These are the loadings, the type of load cases that we have. Then after that, you have the load envelope for each combination 1, combination 2 that we indicate. Then you also have, this is one is trying to show the patterns of the using different load color combinations to show the load cases that we have. Then you now have your bending moment diagram. This is the bending moment diagram, and this is the shear force diagram. You can try and cross check this based on the design load that was in place. Then these are the loads. Then you can now see your analysis result. Your moment is 5. You can see your design moment. You can see your maximum shear force, the design shear, the total load on the beam, the reaction at the support, the type of load, factored and unfactored load, then the reactions for each type of load. Then you can now see the timber section, the breadth, the depth, the number, and the overall bed, and the class strength of the class. That one depend on the moisture content. So we have class. Then going down, you can now see the section property. You can see the modification factor for the timbers. You see the lateral support, compression perpendicular to the grains. So all these are the steps involved in designing a timber beam. So then after that, you see something like past lateral support is adequate. Then applied compressive stress is less than permissible stress at bearing. So definitely, if it is failing, let's say we print the calculation sheet, when the calculation fails, you see something like that as well. So these are your calculations. So let's say you want to design another, you want to have another design. You can easily come here, right click, and add a new document inside this project. So to finish up, if you want to save the project, let's say you want to save this project, you can easily come to save project and save it as anywhere you like to save it. So click OK. Then let's say we want to save this project under TEKLA TEDDS, so we can easily name it as Timber Floor System as the name of our project. So this is the project has been saved. So we save the document as Timber Floor System. We also save the project as Timber Floor System. So let's now say that you are done with the project. You've indicated all the documents you want to indicate. So the next thing is now to generate your calculation sheet. How do you generate your calculation sheet? You can easily come to send TED to Word. That is, you want to send all this calculation sheet to a Word document. So you can just click on this option, send TED for Words. So once you do that, you select all the documents. Let's say you have more than one, so you select all the documents, and you can also arrange it the way you want to be arranged. Then if you want to include the table of contents in your calculations, you can check this. Then you click next, then you click finish. So once you do that, automatically it will load into Microsoft Word. Then once it loads into Microsoft Word, then you'll be able to print out your calculation sheets and even convert it to PDF. So you can see the way the calculation is. This is the header, this is the calculation, then these are the calculation sheets, the load, everything. So from here you can easily convert it to PDFs and then send it to your client. So if you find this video helpful, kindly hit the subscribe button, turn on the notification. See you in our next video.